Algebra 1 students, welcome to your first lesson video. This is section 2.1, solving one-step equations. Alright, so let's start working through filling these out. Anytime as you watch these, feel free to pause the video, rewind, slow down, whatever you need to do. Make sure that you're understanding what we're talking about, and whenever you have questions, come in the next day and ask, and you'll have time to do that. Alright, equivalent equations, equations that have the same solutions. So we can just simply put the word same in there. That's not a definition that we'll use a lot, but it is something to be aware of if you see it. The next two things we're looking at here we will see quite a lot. The addition property of equality. The summary is you're adding the same thing to both sides of an equation. You can add 5 to both sides. You can add x to both sides. In the example that you see here, it says for any real numbers a, b, and c, if a is equal to b, then a plus c equals b plus c. We've added c to each side. Now in the example down below, it says x minus 7 equals 11. The reason we would want to use the addition property of equality is so that we could isolate our variable. So what I'm going to do is add 7 to each side, and I'd have x equals 11 plus 7, which is simply 18. That's why we use the addition property of equality. It helps us solve equations. Similar to the addition property of equality, but just opposite in direction, is the subtraction property of equality. In this case, it says you can subtract the same number to each side, or it could be a variable, I suppose, each side of an equation, and you'll produce an equivalent equation. So in terms of algebra, you'd see it like for any real numbers a, b, and c. If a and b are the same, then a minus c equals b minus c. We've done the same thing to both sides, just subtracted c. Now why would we want this? Well, because by knowing this, we can get x by itself in an equation like you see here. So x plus 7 equals 11, subtract 7 from each side, and you know that x then would equal 4. Alright, so let's take a look at some examples of using these two properties of equality. The first one says x plus 11 is equal to 8. Now again, recall that we're trying to get x by itself, so we would want to subtract 11 from each side. And that would leave us with x equal to 8 minus 11, which is negative 3. I'm going to move down to number 3 for our purposes. We just used the subtraction property of equality. I want to use the addition property of equality, which is what we would run into on number 3. X minus 7 equals 8. We can add 7 to each side, so x then would equal 15. Right now, why don't you guys pause the video and work out questions 2 and 4. When you've finished, hit play again and then compare your work to mine. Welcome back. You can see the worked out solutions for problems 2 and 4. In both cases, we did run into one little variation where the variable was on the right side of the equation rather than the left. That's completely fine. If you prefer to switch it, you could do that. So let's say on the first one, if you'd prefer having it say x equals instead of equals x, you could just trade places and make it x equals negative 13. We're using the symmetric property there to just trade sides of the equation. Alright, moving ahead, we've looked at addition and subtraction properties of equality. We're now going to look at multiplication and division. To summarize, the multiplication property of equality says you can multiply each side of an equation by any number or variable that's not 0, of course, and you won't change the value. In other words, you'd get an equivalent equation. So you can see here we've got x divided by 3 equals 2. In this scenario, I would want to multiply both sides of the equation by 3 because 3 times x divided by 3 is just simply x, and then 2 times 3 of course is 6, and that would be the solution. The division property of equality works in a similar yet opposite way where you can divide both sides of an equation by any number other than 0, and you'll end up with equivalent equations. So you can see in the algebraic step it says if A equals B, then A divided by C equals B divided by C. So if you divide both sides of an equation by the same number, it's still true. Again, the reason we would want to do this is to isolate a variable, so I'll do that on this example. I'm going to divide both sides by 5, and you would see 5x divided by 5 is x, 20 divided by 5 is 4, and that's your solution. Let's do a couple of examples of this. So on number 5 it says 3x is equal to 12. We would want to get x by itself by using the division property of equality and dividing both sides by 3, and we'd quickly see that x is equal to 4. Let's look at number 8. Let's go to that one next. You have x divided by 4, and we need to get x by itself, so we would multiply both sides of the equation by 4. You'll note that I'm using parentheses on this left side. That negative symbol there can get a little confusing if I think it's subtraction instead of multiplication here. So negative 32 equals x divided by 4 times 4. That's simply x. Okay, again, pause the video, work the other two questions here, 6 and 7, and then we'll hit play and compare your answers. Alright folks, now you can see my solutions to problems 6 and 7. Again, compare yours to mine and see how you did, or see how I did if you think yours is right and I'm not. It happens sometimes. Alright, some more terminology. Inverse operations. Inverse operations is the phrase we use when we are describing undoing an operation. We undo operations in the reverse order of operations. So the opposite or the inverse of addition is, of course, subtraction. If I have addition and I'm trying to undo it, I would subtract. Where by the same token, the inverse of subtraction would, of course, be addition. And the other two here, multiplication and division, those two undo each other. We've actually been practicing this on the previous problems where multiplication and division would undo each other, and also addition and subtraction would undo each other. The last two problems we're going to look at are some application problems. This is why we do math. Alright, there's no reason to do math if it doesn't apply to the real world, so that's what we're going to do. A train is 100 miles away from the station. It's approaching the station at 40 miles per hour. How long will it take for the train to arrive at the station? Now, what I'm looking at when I read a question like this is, first of all, what are they asking me to find? Another way to ask that is, what is the variable? We see that with the question when it says how long. That's suggesting that time is our variable. So I'm going to define t to be time, and since our speed of 40 miles per hour is in hours, we should probably do our time in hours as well. So a little bit of a physics equation here. It's a pretty basic one, but essentially what we're looking at is that distance is equal to rate times time. Rate is just another word for speed. And now we can plug in everything we know. Well, we know the distance is 100 miles. I'm going to write this over here so I have a little space to work. The rate was given to us as 40 miles per hour. Time is the unknown. That's the thing we're trying to find. So we would just put our variable t in that place. Now to get t by itself, we have 40 times t. We need to undo the multiplication. Divide both sides by 40. And what we would get is 2 1/2 hours. So the time for the train to reach the station would be 2 1/2 hours. Alright, let's take a look at the last example here. Netflix offers streaming video for $8 a month. Jake's grandma gives him $50 for his birthday. How many months can Jake afford Netflix if he only uses the birthday money from his grandmother? Alright, so again, what is the variable? Well, it says right here, how many months? So again, it's a situation of time. You can define it using the letter T if you'd like. So time is equal to time in, this time it's in months. All right, now we don't have a distance and rate situation, so we got to think about this logically. The cost is $8 per month, so that's $8 for every month. That's 8 times the number of months. And he has $50 that he could spend. All right, so let's look at this. Again, it's a division property of equality situation. 50 divided by 8. And what I know is then that T is equal to, well, 8 times 6 is 48. So that would be like 6 and 2/8 or 6 and 1/4. Now you have to think about the reality of this situation though. Netflix is not likely to offer quarter month subscription rates, so we're going to use a little common sense and say that he could subscribe for 6 months. Starting in month 7, he'll have to find another source of income or perhaps start streaming his videos illegally across the web, leading to a life of crime and punishment. I hope your lesson went well for you. Hope this is going to work, and we'll keep working together. Have a great day.